Hi, this is Calandra with Calandra and Nina's College Algebra Cohort, Week 6. Today we're going to look at linear systems of equations. A system of equations is a group of equations that must all be true. We will typically deal with systems of two linear equations. Recall that a linear function is a function that can be written in the form y is equal to some number that we usually call m times x plus b, where m is the slope. But the key here is it's a linear function if you have an x and y variable and that there are no exponents involved. So we could also write a linear function as some number times x plus some other number times y is equal to some other number if we manipulate that equation by bringing all of the variables to one side of the equation. Okay, so that's linear. The graph of a linear function will be a straight line. The solution to a system of linear equations is the point or points where the graphs intersect. So when looking at the graph of a system of two linear equations, how many solutions are possible? So if the solutions are the points where the graphs intersect, let's see how many ways that can happen. Well, if we have two straight lines, it's possible to draw them so that they intersect only one time. So if they intersect once, that means that there's one solution. Okay, so that's one outcome that we may have. How else can we draw two straight lines if they don't intersect in one point? Well, our two lines may never intersect. So if they never intersect, those are called parallel. And if the solution is where the graphs intersect, these never intersect, that means that there's no solution. And whenever you have this case happen, this is called an inconsistent system. Well, there's one other possibility, and that's if your two graphs are right on top of each other. So this is one of our lines, and then the second line happens to be the same graph right on top. So if they're the same line, that means that they have every point in common. So if they have every point in common, how many points are there on a line? Infinitely many. So there are infinite solutions. And when that happens, it's called a dependent system. Okay, so now let's look at some examples. For the first example, I want you to determine if the point 2, 1 is a solution to the system of equations. Well, the way that we can solve it is if we graph those two equations, look to see if 2, 1 is the intersection point. But that would be the harder way to do it. We can do this algebraically. If this is a solution, it's going to make both of our equations true. So we're just going to plug in our point 2, 1, 2 for x, 1 for y. So in the first equation, we get 2 minus 5 times 1, seeing if that equals negative 3. So we end up with 2 minus 5 equals negative 3, and that works. Well, we can't say that that's a solution to the system yet. It's just a solution to the first equation. So now I need to see if it's a solution to my second equation in the system. So we have 2 times 2 minus 1 equals 1. We end up with 4 minus 1 equals 1. Well, that's false. So that means that this is not a solution to the system. It's only going to be a solution if it makes both equations true. So it's not a solution to the system because it did not make both equations true. And it being the point, 2, 1. Okay, well, how can we figure out the solutions to a system? We're not always going to have a point that we want to check. We're going to want to actually find the solution. Well, there are two methods that we can use. One is the substitution method, and the other is the elimination method. So let's start with the substitution method. To solve a system using the substitution method, first step is to solve one of the equations for one of the variables. Secondly, substitute this value into the other equation and solve the simplified equation that results. Last, give your answer as an ordered pair, x, y. So let's start this with example A. So my first step, I need to solve one of the equations for a variable. So notice we already have y by itself in the second equation. So since y is equal to x minus 7, that means in the first equation, I'm just going to plug x minus 7 in where I see y. So we have 2x plus, now we're substituting in x minus 7 for y equals 3. And now we have a simple linear equation to solve. So 2x plus x is 3x. I'm going to move the 7 to the other side, so we end up with 3x is equal to 10. So my last step to get x by itself is to divide both sides by 3. And it looks like we have a fraction for our answer. X is equal to 10/3. Okay, so remember with a system of equations, your solution is the point where the graphs intersect. So we want to give our answer as an ordered pair. So to figure out what y is equal to, I need to take my x value, plug it into either equation. It will not matter which equation you use because we know this is the point where they intersect. We're going to get the same answer. So I'm going to use the second equation because it already has y by itself. So y is going to equal 10/3 minus 7. And then you can type that in your calculator if you need to. We have 10/3 minus, this will be 21/3, and it's going to give us a negative 11/3. So our answer will be 10/3, comma, negative 11/3. Okay, well, let's go to our second example. So again, we want to solve using the substitution method. So first thing we have to do is to get one of the variables by itself. So in both of our equations, well, in neither of the equations do we have a variable by itself. But it looks like the second equation would be easy to get y by itself by subtracting 2 over to the other side. So in that second equation, you can rewrite that as 2x minus 2 is equal to y. And now I can plug that value of 2x minus 2 into y in the first equation. So my first equation now will be 4x minus 2 times, instead of y, I have 2x minus 2 equals 4. And now we need to solve that. So we're going to distribute the negative 2 to end up with negative 4x plus 4. Still have all of that equals 4. Well, 4x minus 4x is 0. And notice that I'm left with the equation 4 equals 4. We don't have any variable to solve for. We just end up with something that's true. Okay, well, 4 is always going to equal 4. So when you come up with a true statement like that, that means that we're dealing with a dependent system. So these two equations are actually representing the same line. So one way that you can express your answer is in set notation. So we can say that all points x comma y are going to be solutions to this system. I'm going to draw my bar such that, well, what does the relationship have to be between x and y? Well, it's going to have to be one of these two equations. Again, they represent the same line, so it doesn't matter which one you write. So we're going to have the set of all points x comma y such that 4x minus 2y is equal to 4. And that would be our answer. You equally could have chosen the second equation to put into your set. That would also be correct. Okay, so whenever you come up with a statement that's always true and you don't have a variable to solve for, that means you're dealing with a dependent system and every point on the line is going to be a solution. Okay, let's move on to example 3. Again, we want to solve this using substitution, and we already have the second equation solved for y. So I'm going to plug in x minus 7 in place of the y. So let me correct this. I did mean for this to be a y. Actually, let's hold on just a moment. I think I wanted to change this example. Okay. All right, so now we're going to plug in x minus 7 in place of our y. Oh, actually, let's change this, because I just want to make sure you see every type of example. And let's make this y equal to negative 2x plus 7. And let's let this be 2x plus y equals 3. Okay, so that's going to be our starting equation. Okay, so now we're going to take that negative 2x plus 7 and plug it in for y. So that means the first equation is going to become 2x plus, well, instead of y, we have a negative 2x plus 7, and we have that it's equal to 3. So now the two x's are going to cancel out, and we're left with the equation 7 equals 3. So unlike part B, we end up with something that is false. If you have a result that's false, that means there will not be a solution to that system. So our answer would just be no real solution. Or you can write the empty set.